Okay, we are live on YouTube and the recording is in progress. So welcome everyone to the Silicon Valley chapter of IEEE Computer Society event. I'm the chapter chair, Vishnu Pendyala. Ours is the largest chapter in the Silicon Valley section of IEEE with over 3,500 subscribers in our mailing list and a strong following of over 12,300 on Twitter alone. So today we are fortunate to have Raghavendra Chunduri. He is working as a postdoctoral research fellow in the Department of Electrical and Computer Engineering at the University of Colorado, Colorado Springs. He submitted his PhD dissertation in Scalable Machine Learning in School of Information Technology and Engineering at Vellore Institute of Technology in India. He received his master's and bachelor's degrees in computer science and engineering from JNTU, India as well. Currently, Raghavendra is also working as a senior software engineer at Concentrix Corporation in Omaha, Nebraska for the last 14 years. Raghavendra's research interests are in neuromorphic computing, edge computing, deep learning, big data, and machine learning. So today we are going to host him in a Ask Me Anything kind of session, but we'll focus mostly on big data technologies and applications, particularly on the big data processing frameworks like Hadoop, Spark, mining streaming data, and neuromorphic hardware, spiking neural networks, and so on. So, welcome, Raghavendra, to our AMA session. We are really glad to have you. There are quite a few questions for you today. Hopefully, we'll try to cover as many of them as possible. Quite a few of these questions are from my students, graduate students from San Jose State University. So hopefully we'll get to all the questions that they have. So to start with, do you want to say something?
Yeah, yeah. Thanks, Professor Vishnu, for providing me this opportunity to interact with the students and answer their questions, mainly in the area of scalable machine learning and also the neuromorphic computing. Yeah, so I feel this is a good opportunity for me to clarify some of the interesting questions and some important research problems that are there in the current generative AI world. Yeah.
Okay. So the first question I have for you is on neuromorphic hardware. So how does neuromorphic hardware achieve the goal of being energy efficient?
Yeah, so when compared to the neuromorphic hardware with the traditional computers, so the architecture of the neuromorphic hardware itself is a different architecture, and it do not follow the traditional von Neumann architecture that most of the traditional computers follow. So the main purpose of neuromorphic hardware is to mimic the functionality of the human brain, and the hardware is designed in such a way that the communication will be done in terms of spikes, which are the asynchronous event driven messages. So basically, with von Neumann architecture, with the traditional computing world, the communication is done in the form of bits and bytes, right? So, but in neuromorphic hardware, everything is done in the form of spikes, and these spikes are asynchronous and these are event driven. So basically, the processing will occur and the processing will start, and the energy or the transfer will be done or the energy is consumed only when a particular event occurs. So it is all based on a particular event, or it is more like an event driven computing. So since the energy is consumed only on demand, like whenever an event occurs, then only the energy is consumed, and that is how we will save some energy. So the energy efficiency is achieved based on the events and based on the on-demand computation, especially on-demand computation in neuromorphic hardware. So for certain applications, this neuromorphic hardware works fine, like the pattern recognition or computer vision applications. The neuromorphic hardware will be outperformed than the traditional hardware. But coming to the deep learning or NLP tasks, so the processing speed when compared to the traditional computers is almost same. And there are but the research also proves that the energy consumption is less while running any deep learning or machine learning algorithms on this particular neuromorphic hardware. So there is a lot of research that is going on to achieve the better accuracy and better efficiency than the traditional hardware with respect to the computational speed. But the research proves that the energy consumption is very less in neuromorphic hardware than the traditional computers.
Okay, that is quite interesting. Along the lines, can you explain the concept of input energy being proportional to the output in these systems?
Yeah. So basically, as I mentioned, right? So since it is mimicking the behavior of the human brain by using the event-driven processing or event-driven computation, input energy is directly proportional to the output. Depends upon the energy consumption, and this energy consumption is measured, or the energy will be consumed in these systems only when a particular event happens and when a particular processing occurs. So basically, as I said, so any event will be happen in the form of spikes, and the spikes will occur only when a particular threshold or when a particular condition meets. So that is how we save a lot of energy in these systems. So the input energy is directly proportional to the output energy, the output that we are getting in these systems. So
Okay. And in your research experience, how effective and efficient have you found neuromorphic hardware
yeah,
when compared to like traditional computing?
yeah. So as I mentioned, the neuromorphic hardware is definitely outperforming in certain real-time applications like sensor data analysis or pattern recognition or computer vision applications. Neuromorphic hardware outperforms the traditional computers. But when it comes to the deep learning tasks or the natural language processing, the accuracy and the efficiency in terms of execution times is almost as same as the traditional computers, but the consumption of energy is very less when compared to an algorithm that is running on a traditional NLP algorithm that is running on a traditional computer. So there is a lot of research is going on, and personally, we are also doing the research on how we can improve the accuracy and efficiency in terms of computational time and other performance metrics apart from the energy consumption on the neuromorphic hardware. So it is still, the research is going on, and I say at this time it is an outstand it is still in progress research.
So NLP algorithms are different for neuromorphic hardware, or how is it?
Yeah. So most of the NLP algorithms, or most of the NLP algorithms, are based on deep learning and artificial neural networks, right? So, what will happen is, in artificial neural networks, we will have an input layer, we will have hidden layers, and we will have output layers, and there will be some weights and biases between these layers, and that is how a deep learning algorithm works, which is developed on top of ANN, artificial neural networks. But coming to the NLP algorithms, which are specifically developed, which are especially developed for the neuromorphic hardware. So we will have the artificial neural network, which will be converted into a spiking neural network, where the communication happens in the form of spikes, and the model is trained in the form of spiking neural network rather than a artificial neural network, while working on the neuromorphic hardware.
So, for instance, the transformer architecture would still work on the spiking neural hardware? Or?
Yes, so that is a very good question. The transformer architecture is a more advanced artificial neural network, which was trained on the billion number of parameters. Right now, now my research is mainly on that. So implementing the same transformer architecture on the using the spiking neural networks. So there was recently there was a paper that was published on the spike GPT. Basically, like, it is the transformer architecture on the spiking neural networks, but their experiments and their research, actually, I got a chance to discuss their work with the authors of that paper. I got a chance to talk to them, discuss with them. So according to them, still the energy, still the transformer model is energy efficient, but it is not as accurate as a GPT model, because of this large billion parameter constraint. So I'm working with them, and as part of my postdoc, we are planning to develop an efficient transformer based model, depending based on the spiking neural networks. But computationally, and infrastructure wise, it takes a lot of parameters that needs to be trained, which is a computationally costly task. So we are planning to develop a small transformer based large language model using the spiking neural networks, and once we have some good and efficient results on that particular model, we are planning to extend it to the billion number of parameters. So still we are at the early stages in implementing a transformer based architecture using the spiking neural networks.
So yeah, thanks for that answer. Along the lines, are there any other NLP projects that you envisage that might benefit from spiking neural networks?
Yes, so we have the language understanding and translation systems that can be benefited when we implement using spiking neural networks, and we have text classification and the text generation. I mean the language generation using the skipgram and CBOW, bag of words models. So, and mainly the questioning and question answer system is also one of the good application of NLP that can get benefited from spiking neural networks.
Okay, switching gears a little bit. So your research involves exploring various big data processing frameworks and architectures. So when it comes to managing and analyzing large amounts of data, what do you think are the biggest obstacles, and how have they changed recently?
So, one outstanding problem with this large data, or the getting large data, is The data security and privacy is one of the biggest concern. So we are getting lots of data generated from various sources, but we are seeing the security breaches or the privacy flaws in most of the applications or in most of the sources where we are getting this data. So basically, data security and privacy is one of the biggest obstacle that needs a lot of attention by the researchers. And also the quality of the data, since a lot of this data is getting generated, there will be some noisy data, there will be some missing data. So we have to implement some good research techniques to handle the quality of the data as well. So those both are the biggest obstacles that I think while handling this large volumes of data using the big data processing frameworks.
So security and privacy.
Yes.
Mainly. Okay. And in your recent publication, I think it is titled Data Analytics Frameworks for Reliable Bus Arrival Time Prediction.
Yes. Yeah.
So you seem to have underscored the model's proficiency in accurately predicting bus arrival times based on dependable travel time forecasts.
Yes.
So, how do you think this model is different from the already existing applications such as Transit or Google Maps?
Yeah. Basically, whatever the model, the bus prediction system that we have, this model is developed using the ensemble learning techniques, using the support vector machines and artificial neural networks. And we mainly focus on developing a prediction system for the entire transportation industry. And we have started it with the bus arrival prediction. So, what while we are implementing this particular model, right? So, if we consider a Google or an Apple map into consideration, right? So, we will give origin and we'll give destination, and what will happen is it will predict the time, and even these maps will are also able to predict the dynamic changes that are happening. But the actual transportation uh, model, or in the actual transportation domain, it works in a different way. Let's take a bus prediction system as an example. Between origin and destination, a particular bus stops at multiple stations, and maybe there will be some interconnection from one point. There will be an interconnection from different points, and all these needs to be considered. Like, for example, there is a point called let's take an example. Let me explain this with an example. Let's take C as a intersection point where several buses comes from A, and several buses comes from E, and from C, which is an intersection point from where the buses can also visit any other location. So now, if we take that particular system, a person who wants to go to a destination from C to Z, who is coming in a bus that started from A, what will happen is he needs to predict this particular timings of this particular bus, and the bus that is coming from some other location very precisely, so that he can plan his next travel plans. So I think a Google map or a Apple map cannot give accurate timings or accurate predictions if we have a complex transportation model where a person coming from some location called A, who has to catch another bus at a location C, and this bus, the passenger from station A needs to come from another location E. So it is a complex transportation system where it involves multiple routes and multiple buses. So a complex system, a Google Map or an Apple Map cannot handle this complex system. So our system, or our whatever the model that we have proposed, is mainly developed to handle the complex applications like this. And also, we are planning to enhance this particular system to other transportation areas like railroads and truck industry, where, let's say, a truck is carrying a hazardous material or a flammable or an inflammable material. So what will happen is we have to take extra precautions while doing while carrying any hazardous material or anything inflammable. So what will happen is we have to apply several rules to make sure that the journey from a particular location to particular location on the truck will be smooth. So there are some complex business rules that also needs to be predicted. And I think a simple Google Map or an Apple Map cannot handle all of these complex rules that are associated with different kinds of freight that a particular truck is delivering. So our system is developed by considering all of these aspects. And we particularly, first in our first research work, we confined only to developing a complex prediction model. Now we are enhancing by imposing all the transportation rules, and we are planning to enhance this to truck industry and railroad industry.
Yeah, that answers the question. But places like Japan are renowned for their punctual transportation systems, right? So how does Japan attain such commendable precision in transport arrival times, especially before the widespread application of machine learning models?
Yeah. So basically, what happened was mainly the precision in their transportation system is right. So it is because of well-established process and infrastructure. So well established, they have a well-established transportation process, and also the infrastructure. A well designed infrastructure, and also because of the multi-modal integration between the different systems, like they have integration with trams and bus systems, and then the railroad. So they have a very good multi-modal integration system. So because of which they have implemented a very good transportation system. And definitely, with that solid system in place, if Japan, I think they are already doing, but if they integrate all these latest AI based techniques that are there in the transportation industry, I think their system will be much more um, precise and accurate when compared to other transportation models that are exist in the world.
How about your urine application, urine system that you developed? Does it work for other transit modes like trams, metros, or ferries? Or can it be extended for a comprehensive urban mobility kind of solution?
Uh, no, right now, as I mentioned earlier, our model is mainly confined to bus prediction system at this time, like the complex transportation system. But we are working on bringing this to the other transportation industries, and also the multimodal transportation system by integrating different types of transportation models.
Okay, I think your work also touched on FCA. So,
Yes.
be able to explain a little bit about FCA?
Yeah, so FCA stands for Formal Concept Analysis, which is a data analysis technique that is based out of the logic theory and mathematical lattice theory. So basically, the knowledge is identified in the form of concepts for any given input, and then now and it is represented using the lattice, where the identified concepts, which actually contains knowledge, is hierarchically organized in the form of lattice. And because of this lattice representation of the knowledge, we can always traverse from either top to bottom or bottom to top to get the useful information out of the given input. So FCA is one way considered as an unsupervised machine learning technique, and several domains like natural language processing, data mining domains, and machine learning domains are heavily using the formal concept analysis. But because of this growing size of the data, scalability is an important factor that affected FCA to confidently you apply in these particular domains, whatever I'm mentioning. So my work, our research mainly focus on implementing the scalable FCA models so that it can be easily integrated to any of these domains whenever an efficient data analysis is required. And because of its mathematical capabilities and the logical capabilities that FCA supports, it is a more efficient data analysis technique when compared to other data analysis techniques that are available.
So are there any real world applications of FCA today?
So yeah, there are some real world applications, but actually they are not implemented on the applications which requires a large data sets. But yes, in some of the e-commerce applications, the FCA is being used, and also in the health industry for patient diagnosis and all. FCA has been heavily used, and also for language, for the NLP, some of the NLP tasks for the text generation and all, FCA is being used.
Okay, and so do you think, I think there is a scope for integrating machine learning models, right? So, and also algorithms like FP growth and big data frameworks like Apache Spark. Can you just talk a little bit about the integration of these frameworks?
Yeah, sure. So yes, FCA is a mathematical data analysis technique which can be used in the domains like data mining and machine learning and deep learning. But the beauty of FCA is also can be benefited from these domains. Like in FCA, there is a concept called implication theory, which finds the relationship between the attributes in the given input. So to find those to find the relation between the attributes in the given input, so we cannot we can also use techniques like a priori algorithm or FP growth algorithm, which is also called the rule based machine learning techniques, to identify the relationship between these objects. So the beauty of FCA is two-way. So we can use FCA in domains like machine learning and data mining, and uh, the domains like machine learning and data mining are also used by FCA for the data analysis. And then, as I mentioned, the scope of applicability, or the scope of FCA is being restricted because of its uh, inefficiency to handle large data sets. So some of the scalable algorithms or the scalable models that we have proposed will address those capabilities, will address those some of those issues that are there or that are present while using FCA for the large applications or the big data applications. So we have used the big data processing frameworks and designed the FCA models, like the models like MapReduce and Apache Spark. We have used these models to design the FCA based models as part of the scalable FCA research.
Okay. And what are some of the key challenges in implementing the lattice construction algorithm using graphics? Apparently, you seem to have used this, right?
Yeah.
How did the graphics help to distribute and parallelize this process?
Yeah. So one main challenge is, so in lattice, basically the elements of the lattice are organized by a relation called partial order relation or the POSIT relationship. So whenever we generate concepts using the big data processing, we have to maintain that POSIT relationship between the concepts that are being generated, and then while constructing the graphs, we have to consider that relation into picture while designing while designing the lattice. So the lattice, using the graphics, we are designing uh, the lattice as a graph, and also while constructing this particular lattice graph, we also have to maintain that partial order relationship between the nodes in the graph. So that is one of the challenges, and we have implemented that challenge by generating the concepts, and we have given a parent id, or we have given a unique identifier for every concept that is being generated, and then using that unique identifier we use to identify its parent concept. And while constructing the graph using that unique index concept, we identified the layers in the graph, and we have constructed the lattice graph. And since the distributed processing techniques or the distributed functionality of the graphics module in Apache Spark, so even though we have large number of concepts generated for a given input context, those are distributed across various nodes, and using the graphics using the graphics module in Apache Spark, we constructed the large lattice graph in a distributed way, which helped us saving lot of time while constructing that lattice graph.
Okay. Yeah, thanks for that answer. And a general question. How does the conversion from a pre-trained artificial neural network model to the proposed spiking neural network model take place usually?
Okay. Yeah. So what usually when we have a trained ANN model, so we will have the weights of the model, the trained ANN model. We will have the weights. So what we do is while converting an ANN model to constructing an SNN model from scratch is a very complex task, and it is not easy, which is computationally inefficient. So the research, whatever the research that is going on in the area of neuromorphic computing and spiking neural networks, is always suggested the best way is to construct an ANN first and then convert this ANN to a spiking neural network. So what we have what we can do is, so we can always save the weights of the ANN model, and then convert all of this ANN weights into the spikes. So there are some tools that are available within the SNN framework, which will take care of this ANN to SNN conversion. But still, while doing this ANN to SNN conversion, still energy efficiency is a open problem. We, since we are first creating an ANN model, we do not see any better improvement in the energy efficiency. So when we are really dealing with large language models or models that require large input data set, training of the large data sets, it is always recommended to create an SNN from scratch, and we can do that by creating the input layer, and then subsequently identify the events that are required by defining some thresholds, and then designing the output layers and designing an SNN from scratch. So there are some tools that are also available to design these SNNs from scratch.
Okay. Can you just elaborate on the computational resources required specifically for running your SSA Spinnaker model? Like what specifications are needed in terms of hardware and software to effectively deploy this?
Yeah. Yeah. So we need the neuromorphic processor to run this SNN based models. So there is a open source SNN license available, open source hardware, neuromorphic hardware available, and it is called a Spinnaker system, which was funded by Human Brain Project and the European Research Society. And this large neuromorphic hardware is hosted in the University of Manchester, UK. And what they do is they are providing licenses. Those are the open source licenses, but there is some process to obtain a license. So we have to contact the Human Brain Project team, and they'll help you to. They'll set up a workspace. They'll set up a account and everything. When based on the request, and then once we get the access, we can there is everything, like there is a Python Jupyter notebook, and there is all an editor kind of thing where you can always develop, you can write your own models, you can develop them, and then you need to access that terminal and start running the models that we have implemented. And then it is deployed on the cloud, and you can run your models on that particular hardware. But whenever as I said, if we are developing a large language model with trillion or billion number of parameters, that needs a special licensing and special computer requirements. So we have to request for those in order to get in order to run those large language models. So but when you have a medium size or a finite input size data, I think the Spinnaker hardware is sufficient to run the model. And there are also some commercial hardwares like BrainChip and Akida are available. uh, they'll give some credits for free, and once the credit expires we need to take a subscription, like how we take on AWS or GCP, and start running our models.
So there is a free tier for Spinnaker also. That's what you're saying.
Yeah, Spinnaker is always free because it is directly funded by the Human Brain Project and the European government. But for running the large language models, and if you need more number of cores or more number of processors, you need a special license. Otherwise, if you have a decent size of data and your model is decent size, then I think the normal Spinnaker is sufficient.
Okay, and what kind of anomalies or issues did you encounter when working with the real-time bus arrival prediction using neural networks? And how did these anomalies differ from those you may have seen in historical data sets?
Yeah, so basically noisy data and missing data. Like, so for example, while we are using on a real time data, and while we are predicting bus well we are predicting the timings of a bus at a particular location. Let's say we have a missing report, we have some data missing, or we have the previous stations actual times are missing in the data, current data that we have. So if the previous station data is missing, it is going to be it is going to be hard for our prediction algorithm to work and predict the timings at the timings of the next station, or the all subsequent downward timings. So that is one major challenge. And also the noisy data, where the data is not in a proper format, or basically, like whenever there is a sudden changes in the route, and the route is dynamically changed once the model once the bus starts, and if the route changes again, or if the data is not very accurate, and if the data has some noise. So those are some hard things that needs to be handled in the bus prediction system. So we handled only the missing data by considering the statistical measures, like the mean and the median, to consider and update the timings at the missed to update the reportings at the missed stations. But still, the noisy data and the latency are some of the outstanding problems that we have in that research.
Okay. And can you give some insights into the Spark concept generation algorithm when handling large data sets?
Yes. So Spark concept generation algorithm is one of the FCA algorithm that that we have designed to handle large data sets and identify the knowledge out of the large data sets, and then find the concept lattice to represent the identified knowledge. So we have used Apache Spark to design this particular model, and Spark's default in-memory computation and also the fault tolerance techniques helped us to achieve the scalability efficiently. And we have also optimized some of the performance to achieve the efficiency in performance. We have also fine-tuned some of the parameters, like the size of the heap, the number of core processors, and increasing the size of the memory to allow space to more in-memory computations. So we have efficiently utilized the resources that we have, the limited resources that we have in terms of memory or CPU, and we achieved a good performance efficiency using those limited number of resources.
So, are there any real-world applications which can benefit from this algorithm?
Yeah, so there are some real world applications, like some of them are the e-commerce applications, where we need to e-commerce instance the recommendation systems, or the tech or when we need to classify the data, um, in the like in classification or the applications that are the recommendation systems, definitely this scalable algorithm based on Spark FCA is really used to achieve the best performance.
Okay, and in your research paper, you also talked about three-way decisions, right?
Yes.
Can you throw some light on that?
Yes. So basically, like in formal concept analysis, the input is in the form of a matrix or is in the form of a object attribute table where we have objects and the attributes that are associated with these objects. So in formal concept analysis we only consider the positive attributes, meaning the objects that possess the particular features or the objects that possess a particular attributes, and we categorize these attributes, meaning the attributes that are the features that are there in a particular the object that carries certain features or that has certain features are categorized as the positive attributes, and the attributes that do not have or the objects that do not have the features or the features that are missing for a particular object are categorized as negative attributes. And in formal concept analysis, which I say the classical formal concept analysis, we cannot consider these negative attributes. We only always identify the knowledge using only the positive attributes, meaning the objects or the that possess particular features. But it is also important that with this data driven world and with this large data generation from various sources, it is also important to consider the negative attributes, um, because the thing is like, so whenever we are let's take a recommendation system as an example. So now what we are doing is, so we are purchasing an item based on the recommendations that are there for a particular product, right? But now the users are also very much keen interested, or the users are also focusing on if a particular person recommends a particular product. There are people also need, if someone is not recommending that product, people are also very keen to understand and know about why they are not recommending, what are the issues or what are the drawbacks with that particular product. So they are also considering the negative attributes, I say the features that are there that are not present in a particular product. So everything matters in this data driven world. So positive attributes are important, and also the negative attributes are also important while doing the data analysis. So that is the main objective of the three-way concept analysis, and that is where so while generating the concepts using three-way concept analysis, we need to identify the concepts that are related to the positive attributes or the positive features, and we also need to identify the attributes concepts that are related to the negative attributes. So both are important for the data analysis. So that is the reason why the three-way analysis came into existence, and our distributed algorithm construct identify the concepts of the positive attributes and identify the concepts of the negative attributes simultaneously to save the time.
Okay, yeah, that makes sense. Uh, so you also mentioned that attribute induced and object induced concept lattices are created, right? So could you please provide some insights when it is preferable to use object-oriented or object-induced concepts, lattices, and when it is preferable to use the attribute-induced concept lattices?
Yeah, sure. So attribute induced concept lattices are typically used when the focus is on understanding attributes or features and their relationship with the objects or entities. So, an attribute induced concept lattices are very well suited for applications where users wants to analyze and categorize attributes based on the commonalities and differences. So, for example, let's take a document classification example. So in NLP world, right? So attribute induced lattices can help in classifying the documents based on the shared features. Like what example, like the keywords or topics. So we can use those attribute induced lattice to identify or to classify the documents uh, to assess the process of information retrieval. And coming to the object-induced concept lattice, object-induced concept lattices are mainly used when focus is on understanding objects or entities. So in attribute-induced concepts, our object is mainly on attributes or features, but coming to the object-induced concept lattice, our focus is mainly on understanding the objects or entities and their relationship with attributes. And for the applications which are mainly benefited based on the object classification, object-induced concept lattice is a very good technique. So, like while doing a disease diagnosis, object-induced lattices is one of the best technique that can be used based on the symptoms that a particular patient has and based on his medical history.
So we have all these concept hierarchies. How do you think they can be used to solve NLP related tasks? Can models like GPT use this knowledge to get more accurate results?
Yes, but actually, we can use these models in NLP or NLU, natural language processing or the natural language understanding task, uh, to achieve high accuracy and to get a great benefit. But again, the models like GPT, which are trained on a billion number of parameters, I think this is going to be an outstanding. Research, I mean, this is going to be an open research problem in the area of FCA domain to fit or to use this FCA in those large transformer based architectures. Definitely, there is a possibility to integrate, but it requires it requires to address some of the research gaps that are there while adopting FCA in transformer based architecture.
Okay. One of my students has a general question, relatively general. So, what factors should researchers and developers take into account when implementing scalable algorithms in big data processing to guarantee both computational efficiency and the preservation of data integrity, particularly in situations involving complex data structures or high dimensional data?
Yeah, so one thing is the first thing that we have to take care of is the fault tolerance. So, fault tolerance is really an important aspect that one has to taken into account while designing scalable algorithms that work on large data sets. Because when a failure occurs, uh, the model should have capability to construct itself, uh, to recover itself automatically and start or resume its execution, or the process or the computation transferred to another working node. So fault tolerance is one of the important factor that needs to be considered, and also efficient load balancing, which I say. So while working on the large models, we have to efficiently manage the load balance, because one worker node should not be busy with the computational tasks, and one should not be free. So we also needs to consider that important factor. And then the data quality, where the input data should be handled efficiently in such a way that the data is in a very good quality. And then efficient techniques for the scalability. So even we are implementing a scalable algorithm on the large data sets, we also needs to consider the efficient performance parameters of the efficient fine tuning parameters. They needs to be optimized correctly to achieve the better results. So fine tuning parameters is also an important factor that needs to be considered while implementing any scalable model.
And how does your UN concept generation method tackle common issues like slow internet speeds or data transfer hiccups? And how does it set up? How is it different from other similar techniques?
Yeah, so the UN concept generation algorithm that we designed and we have proposed in one of our initial papers was based on MapReduce framework and Hadoop. So whatever the common problems that we have in Hadoop and MapReduce framework were also present in in the proposed the UN concept generation algorithm. So basically, the fault tolerance mechanism that we have implemented, or the parallelism that we have implemented, those are some of the common issues that we have identified. Even so to your question on the data transfer hiccups and slow internet speeds. So while working on the physical hardware, we have identified some of these issues, like since we have a cluster of 3 to 4 computers, which we set up, and trying to run Hadoop, trying to make an Hadoop cluster, we do have some issues with the internet speeds and all. But once we moved to the cloud environment, uh, we have not seen any of these issues. So what I can suggest is, it is always recommended to use the cloud environment if if you have provision, and if you have scope to deploy all of your models rather than the physical clusters.
And related to that, do you think the UN concept generation algorithm can adapt to the more recent distributed processing paradigms outside of MapReduce, like say Apache Flink? Um,
Yes. Yeah. So we can always use streaming frameworks for, and we can always use data streams. But compared to the Apache Spark streaming, Apache MapReduce streaming is not very efficient while handling the large data sets. So in our latter works, we proposed the concept generation, or we proposed the FCA algorithms for the streaming data sets as well, using the Apache Spark. So I can say, rather than using the Spark streaming, rather than using the MapReduce streaming, if we adopt uh, the Spark streaming, I think we can achieve efficient results.
okay, now switching back to spiking neural networks. Do you think they can be used to create therapeutic interventions that enable individuals to regulate their emotions or enhance their mental health in a more tailored and effective manner?
Yes, so that is the main objective of bringing these NLP and NLU models onto the neuromorphic hardware. Uh, I still say it is an open research problem, but we can always, that is the main goal of NLP. NLP. So the main goal of NLP is to mimic the behavior of the human brain. So we can also, so while doing that, so we can develop the models like the emotion recognition or neurostimulation models and other predictive models to understand the human's mental health, and we can do that. So that is mainly like the AI based, we can call it as an AI based mental health model, but the functionality or the object, the design of this neuromorphic hardware is mainly helps to come up with an efficient uh, model that almost mimics the behavior of the human brain.
Okay. And apparently, in your paper, you also talked about FPGA-based hardware architectures for your models, right?
Yes.
So, can you shed more light on that?
Yeah. So developing and running uh, or using the FPGA based hardware for neuromorphic models, right? So they are mainly used to get the power efficiency. So we can power efficiency is one of the important factor which we can uh, achieve using the FPGA based models in the neuromorphic hardware. And then the scalability and the parallelism and the low latency are some of the important factors or the important performance metrics that can be optimized by bringing FPGA based designs. So for the real-time NLP tasks or the natural language understanding in autonomous vehicles, I say FPGA-based architectures are more helpful. FPGA-based models are more helpful by integrating them with the neuromorphic hardware.
So, I think some of the models can be implemented in FPGA. Is that the idea?
Yes, yeah. Some of the models can be leveraged to FPGA.
Oh, okay. Okay, and you said privacy and security are the biggest concerns. So, do you have a vision, or how do you see the future with big data in the light of security and privacy?
Yeah, so with this generative AI, with this generative AI demand, right? So the responsible AI and the privacy preserving AI, and also the ethical AI, and then the AI for the security are some of the important aspects that we can consider to achieve the privacy preserving to achieve the privacy preservation, and also the to address the security aspects in the machine learning and artificial intelligence world. So right now, again, it is an open research problem to the industries that are actively working on the privacy preserving and security. But personally, I did not get a chance to work on any security related research so far in my research career. So
Okay, yeah, that's reasonable. Uh, so let us talk about a little bit about dynamically evolving data sets, right? Like, so how do you think the scalability and real-time processing capabilities of, say, the Spark framework be used to improve the production and analysis of formal ideas in rapidly evolving data sets?
yeah, yeah. So Spark streaming is one of the important concept or one of the important feature that is there in the Apache Spark, which is really helping to process the dynamically evolving data sets. So it can always process the real-time streaming data to find the useful information out of it, or for the efficient data analysis. But when the concepts are, so there is also some of the issues which lead to the future directional research, especially in the formal concept analysis world. So we can always do the data analysis. We can always perform data analytics by generating the concepts and constructing the lattice graph out of the data that is already available. Or even in the streaming data sets, we can do this concept generation and lattice construction. But when the data is really growing fast, I mean, when the input is really growing fast, so there is a chance that when considering the data, we will end up taking incomplete input. So that is still an open research problem, which also needs attention from the researchers in FCA world to handle the incomplete data and dynamically growing data accurately, and handle it, process it, and identify the important patterns or the useful insights out of it. So I say we can definitely handle the streaming data using or the dynamically growing data using Spark streaming, but still there is some research that needs to be done to handle this data efficiently and completely to perform data analysis.
Okay, in your experiments or in your work, did you see a trade-off between speed and accuracy? Like you used FP growth algorithm, right? With
Yes.
Spark. So was there a trade-off really between the speed and the accuracy or comprehensiveness of the generated implication base?
Yes. Yes. So yeah, so this is one of the first distributed algorithm that is available in the literature for generating the implication base using or generating the implication base in FCA using Apache Spark. So most of the works that are that exist in the literature, what they do is they use most of these works, what they use is they use the concepts. So in order to identify the implication base, we need the formal concepts needs to be figured out first, and then from the identified formal concepts, we the existing algorithms or the works in the literature generates the implication base. But our work or our model is designed in such a way that it proves that the formal concepts are really not needed while identifying the implication base, and implication base can be generated directly without the calculation of formal concepts. And also, we proposed this algorithm to work in polynomial time rather than exponential time. And by adopting Apache Spark, the in-memory computations and the parallel or the distributed processing that Apache Spark supports also speed up our execution while generating implication bases in the large data sets.
Okay. Yeah, thanks. Um, so the next question I have is on model interpretability and explainability, right? Um, so the SNNs are obviously more complex. So what are there any methods or tools available to understand why the SNN model made a specific prediction for a given input?
Yes, so there are some visualization tools, and there are some feature attribution methods, and the attention mechanisms that can be used. And some of these features are directly present in the Spinnaker hardware itself to to generate all these visualizations between the artificial neural networks and spiking neural networks, and to get a detailed understanding on why spiking neural networks is better while the energy consumption, and what is the issue with, and what is the issue with the artificial neural networks. And then the accuracy, we can also get the visualizations of the accuracy between the ANN and SNN models. So all of these add-ons are available in the Spinnaker hardware, using which we can always monitor these.
Okay, so it's mostly like visualization and stuff like that.
Yes, yeah.
Okay. Um, so for real world deployment, right, what considerations around infrastructure, tuning, or operations would you highlight for getting the best performance out of Spark for this type of workload?
Yeah. So there are some optimization techniques, and there are also some optimizer frameworks that are available on top of Apache Spark, like Tungsten is one of the efficient optimizer for Apache Spark. So we can always, and there are also list set of fine tuning parameters that are available while executing the model, while executing the Spark based model. So we can always fine tune those configurations than the default configurations, using which we can always achieve better accuracy and better performance when compared to the other models that are implemented other than Apache Spark.
So if we focus on performance, will it minimize or increase the energy consumption?
So yeah, when we focus on the performance, definitely not, because I mean, again, I take that back. So again, it depends on the fine tuning of the parameters. Let's say, to achieve a good performance, we are increasing the size of the number of CPU cores. Obviously, the energy the energy consumption will be more. So it all depends on how wise we are choosing those parameters, and how wise we are fine tuning them, so based on which we can efficiently handle both performance and energy.
Okay, so
So if we perform more in-memory computations, obviously it results in the lot of data transfer. It results in reducing the data transfer between the data sources and the computing nodes that are there in the execution environment. So, and always the data, since the data is available in the same memory, in memory for a particular computer, it can always take the data efficiently and run the computations faster than taking data from a particular data source. This will improve both energy efficiency and also the computational efficiency by minimizing the cost of energy that occurs between for the data transfer, and also the computational cost of the time that is taken for the data transfer. So those will be minimized, right? So it all depends on how wise we have chosen those parameters.
and this is applicable to even dynamic contexts like robotics or autonomous systems.
Yes, yes.
Or do we have to think anything special for them?
Yeah, definitely, we have to think, but for a basic model, or for the basic model, I think this is sufficient. But when we are coming up with a autonomous vehicle model, or a robust AI applications, so it requires a lot of training data. The data needs to, it needs to be, the model needs to be trained on the billion number of parameters, and also there will be a lot of rule base that is present. So the training of these models is different from the models or the smaller models that we are using. So it varies, depends on the model that we are developing. So
Okay, yeah, that's fair enough. Um, and so, what are the future directions for your work on FCA? Do you have any specific ideas about how these methods could be improved or optimized further?
yes. So one thing is, the all the models that are proposed in our research are mainly executed on the CPU based environments. So I say we need to implement these models on the GPU based hardware and see how efficient they are while identifying the concepts and constructing the concept lattice. And then for the concepts or for the input for the data that is dynamically growing, or the incomplete formal concepts, the data that is incomplete, or the data that the data quality is not really good, before processing it on the FCA, before processing or running the FCA on it. So all these things needs to be handled in the area of FCA research.
So in our discussion, we haven't talked about GPU servers. So do you think your algorithms will benefit from GPU servers? Because recently NVIDIA is evaluating Spark query performance and measuring the significant improvements
Yeah.
using GPU. So will this be the case for formal concept generation algorithm also?
So these models need some slight configuration changes, and then these models needs to be fine tuned little bit to in order to support the GPU based executions. So the GPU based scalable FCA model is still a kind of open research, or is still a kind of open problem.
Okay. No discussion is complete on AI without talking about AI and big data, without talking about ChatGPT. And you have been working in the NLP area quite substantially. So, what do you think will be the next breakthrough in natural language processing? Do you think ChatGPT based models or GPT based models can eventually replace human beings?
I don't think so. They do not replace human beings, but they assist human beings. So rather than replacing, I think they are good assistants for the human beings, because mimicking the human brain is possible, but it is not 100%. So no AI based, I mean at this time, no AI based system uh, can replace a human brain, but they are good assistants for the humans, because with the chat GPT also, right? We can ask several questions and it will answer, but they do not have the thinking or the logical capability like a human brain. For example, the first time, and with the RLHF, reinforcement based learning, based on the human feedback, these systems are getting benefited. The GPT based systems are getting benefited, but still they are not as intelligent as humans. Because like when I first time asked a GPT system about COVID, I just asked about which is best, positive or negative, and the GPT based system or the chat GPT has answered me, positive is always best. And then immediately my next question to it is, so do you think COVID positive is better? Then it said no. But if you ask a human being, the first answer will be like, positive is sometimes better and negative is sometimes better. And again, it all depends on the context. So that is how a human being will answer. and these GPT systems are lack of that intelligence, so which can be achieved eventually, but not in a very short span of time or in a near time frame.
Yeah, that's fair enough. So I think we went a little over the time, and I don't see any questions in the Zoom chat or on YouTube live. There are 4 likes on the YouTube channel, but there are no questions. So to end the session, do you want to say anything else from your side?
No, I'm good, and thanks for providing me this opportunity to participate in this AMA discussion. And I really had a, I mean, there are some very good questions that are really interesting. Yeah, and thanks for providing me this opportunity.
Yeah, thank you. The answers were quite insightful, and my students will be thankful to you as well, because quite a few of these questions were from my students.
Okay.
They actually read through your papers and they came up with these questions. So, if it was a live event in San Jose, we could have given you a plaque. But since this is an online event, I wish to present you with the certificate of appreciation.
Okay. Yeah.
Really, thank you for today's conversation, which was very insightful. The recording will be on YouTube. So for viewers to watch in future as well, so that is good. So I just want to end with the events that we have lined up. So today's event was this: Ask Me Anything on Big Data Technologies and Applications. Oh, sorry. So next month we have a talk on the hot state machine, a runtime loadable microcoded algorithmic state machine by Steve Castleman. This should be really very interesting. It's on the 5th of December, Tuesday at 6 p.m. And we start the new year with my talk, which will be on representation learning in lower dimensions and spectral methods in machine learning. So I'll be talking about eigen decomposition, manifold learning, and stuff like that. So please feel free to attend. And thanks for attending today's session. And particularly thanks to the speaker, Raghavendra. Hopefully we'll be in touch and hope to see you in some of our future events also. Thank you.
Yeah. Thank you. Thanks, Professor. Thank you.
Yeah, thanks.